Good morning, students. Next lecture of chemical kinetics is collision theory of chemical reactions. Collision means collide. So what is the meaning of this collision theory? That when the reaction take place, the reactant molecules, they collide with each other. This is the base of this theory. So for the reactant to change into product, there must be collision, that the reactant must come close to each other. Then only the product is possible. So this is the collision theory of reaction rate. Now, according to this theory, the basic condition for the chemical reaction is the collision among the reacting molecules. Like if we have two molecules, A plus B, to form P, so this A plus B, they must collide. They must collide with one another. This is the basic condition for the collision theory. And number of collisions taking place per second. Number of collisions per second. Number of collisions per second per unit volume of the reaction mixture. Number of collisions per second per unit volume of the reaction mixture. Is called collision frequency. Is called collision frequency and represented by a Z. So number of collisions per second per unit volume of the reaction mixture is called collision frequency and it is represented by a Z. Since the collisions are taking place at a very fast rate, the value of collision frequency is very high. That means you can say that the collision frequency is in the order of 10 is per 25 to 10 is per 28. Generally, its value is 10 is per 25 to 10 is per 28. So this large number of collisions taking place in a short time, in a 1 second. These are the number of collisions per second per unit volume of the reaction mixture. So this means that chemical reactions with such a high collision frequency must be extremely fast. अगर इतनी ज़्यादा collision frequency है, इतनी ज़्यादा collisions हो रही हैं continuously 10⁻25 to 10⁻28 per second, तो इसका मतलब है reaction that should be very fast. But actual में जब हम observe करते हैं तो reaction जो है वो उतनी fast नहीं होती. इसका मतलब क्या हुआ? इसका मतलब ये हुआ कि जितनी भी collisions हो रही हैं वो सारी की सारी collisions से product नहीं बनता. Means all the collisions, अगर सारी की सारी collisions से product बन रहा हो तो reaction जो है बहुत fast होनी चाहिए because this is a very large number. 10⁻25 to 10⁻28 collisions per second is a very large number. इसके हिसाब से तो reaction rate of reaction that should be very fast. बट एक्चुअल में क्या हम देखते हैं कि रेट ऑफ रिएक्शन इतनी फास्ट होती नहीं. इसका मतलब क्या है कि जितनी भी collisions हो रही हैं वो सारी की सारी इफेक्टिव नहीं है. collision जो है वो दो तरह की है. एक को बोलते हैं इफेक्टिव, एक को बोलते हैं इनइफेक्टिव. इफेक्टिव collision वो होती है जिससे प्रोडक्ट बनता है. इनइफेक्टिव collision वो होती है जिससे प्रोडक्ट नहीं बनता. ओके. So in order to make the collision effective collision का मतलब क्या है? In which the product is formed. Then only you will say this is effective collision. That two molecules collide, product is formed. If the two molecules collide, nothing is formed. That is called a ineffective collision. No product. So for the collision to be effective, there are two barriers. For the collision to be effective, there are two barriers. यहाँ पे दो बैरियर है हमारे पास. फर्स्ट बैरियर है एनर्जी बैरियर, और सेकेंड बैरियर है ओरिएंटेशन. Orientation barrier. Energy barrier means in order to make the collision effective तभी होगी if A and B must have a minimum amount of energy. अगर A और B के पास कुछ मिनिमम अमाउंट ऑफ एनर्जी है तभी वो collision जो है इफेक्टिव होगी. ओके, सो collision will be effective only if A and B means reactant must have a minimum amount of energy, that is known as a threshold. उसको हम बोलते हैं थ्रेशोल्ड एनर्जी. सो मिनिमम अमाउंट ऑफ एनर्जी उनके पास होनी चाहिए. अगर रिएक्टेंट के पास मिनिमम एनर्जी से कम है तो वो रिएक्टेंट जो है वो प्रोडक्ट प्रोड्यूस नहीं कर पाएंगे, उसको बोलेंगे इनइफेक्टिव. इट मींस आउट ऑफ दीज 10⁻25 to 10⁻28 वो collision इफेक्टिव होंगी जिनके पास मिनिमम अमाउंट ऑफ एनर्जी है, दैट इज अ थ्रेशोल्ड एनर्जी. या तो थ्रेशोल्ड एनर्जी के इक्वल होनी चाहिए उसके पास, या उससे क्या होनी चाहिए, ज्यादा होनी चाहिए. दूसरा है हमारा ओरिएंटेशन. ओरिएंटेशन में क्या आता है कि जब भी कोलिजन हो द मॉलिक्यूल मस्ट बी ओरिएंटेड इन अ पर्टिकुलर वे. ओरिएंटेशन जो है, ओरिएंटेशन मस्ट बी प्रॉपर. अगर प्रॉपर ओरिएंटेशन होगी तो प्रोडक्ट बनेगा, अदरवाइज नहीं. कैसे, इसकी मैं एग्जांपल ले रहा हूं. इसकी एग्जांपल है CO plus NO2 to form CO2 plus NO. अब इस केस में when a carbon monoxide molecule that combine with this NO2 molecule, so there must be different proper orientation, no? Like say this is suppose your C, this is your O, CO. Here is your N, O, O. This is CO, this is NO2. So this collision, nitrogen collide with carbon, no use, because new bond is formed between carbon and oxygen. Okay, so nitrogen reacting molecules not properly oriented. So reacting molecules are not properly oriented, so ineffective. Collision is ineffective, no use. Okay. Second is, say here is oxygen, here is carbon, here is oxygen, nitrogen, oxygen. So this oxygen collide with this oxygen. Again the reacting molecules are not in proper orientation, so collision will be again the ineffective. Third one is like here is a C, here is a O, here is O and O. So there is a collision between carbon and oxygen. This is effective because carbon combined with oxygen of NO2. So this is your effective collision. That will give rise to the product. So this is about the collision theory. And these are the two barriers which collision to be effective. पहला तो उस रिएक्टेंट के पास मिनिमम अमाउंट ऑफ एनर्जी होनी चाहिए. दूसरा उसकी प्रॉपर ओरिएंटेशन भी होनी चाहिए. ये इसीलिए अगर 10⁻25 to 10⁻28 कोलिजन्स हो रही है पर सेकेंड, उसमें से जितनी भी कोलिजन है वो सारी की सारी इफेक्टिव नहीं है, इसीलिए एक्चुअल में रेट ऑफ रिएक्शन उतनी फास्ट नहीं होती। तो कुछ वही इसमें से कोलिजन कौन कौन सी इफेक्टिव होगी, वही होगी जिनमें इनके पास एनर्जी जो है वो थ्रेशोल्ड एनर्जी से ज्यादा है, या जिनकी जो कोलिजन है वो प्रॉपर है। आप देखो ये कोलाइड कर रहे हैं, कोलिजन में काउंट हो रहा है लेकिन प्रोडक्ट नहीं बन रहा, दिस इज इनइफेक्टिव। तो इसमें से कितनी सारी ऐसी होंगी, ये कोलाइड हो रहे हैं, नो प्रोडक्ट, ठीक है। ऐसे ही अगर ये दो कोलाइड हो रहे हैं लेकिन उनके पास एनर्जी नहीं है, देन अगेन दैट विल बी अ नो यूज। So this is about the collision theory. Now next is a temperature dependence of rate of reaction. शुरू में हमने कुछ फैक्टर्स किए थे, तो उस फैक्टर्स में था एक टेम्परेचर का फैक्टर, नेचर ऑफ रिएक्टेंट था, कंसंट्रेशन ऑफ रिएक्टेंट था, अगेन टेम्परेचर था, उसके बाद कैटालिस्ट था। तो कंसंट्रेशन ऑफ ऑर्डर ऑफ रिएक्शन पढ़ चुके हैं। इफेक्ट ऑफ टेम्परेचर अब हम करेंगे। इफेक्ट ऑफ टेम्परेचर। सो ऑन इंक्रीजिंग टेम्परेचर रेट ऑफ रिएक्शन इंक्रीज, सीधी सी बात। ऑन इंक्रीजिंग टेम्परेचर rate of reaction increases, and generally it is found that with every 10 degree rise in temperature the rate of reaction increase 2 to 3 times. 10 degree rise in temperature, the rate of reaction increases by 2 to 3 times. This is called its temperature coefficient. This is called its temperature coefficient. We can write it like Tc. So what is temperature coefficient? It is defined by alpha and defined as ratio of rate of reaction at two different temperature differ by 10 degree. Alpha से लिखेंगे ratio of rate of reaction at two different temperatures differ by 10 degree. So rate at T plus 10, rate at T equal to alpha. Or we can say that rate at 35 degree, rate at 25 degree is alpha. और अल्फा क्या होगा, 2 से ज्यादा 3 से कम। क्लियर? तो with rise in temperature, rate of reaction that increases to 2 to 3 times. The reason behind it is that with increase in temperature, what happened actually? Number of effective collisions increases. जैसे ही टेम्परेचर बढ़ेगा, देखो एक तो एनर्जी बैरियर कवर हो जाएगा। एनर्जी बैरियर मतलब जब हम टेम्परेचर इंक्रीज करेंगे तो रिएक्टेंट को एनर्जी मिलेगी और उनकी एनर्जी ज्यादा हो जाएगी। किससे ज्यादा हो जाएगी? जिसकी थ्रेशोल्ड एनर्जी से ज्यादा हो जाएगी। ओके, अगर हम फ्रैक्शन ऑफ मॉलिक्यूल, अगर हम काइनेटिक एनर्जी के हिसाब से इसको मॉलिक्यूल को देखें तो इसमें इसको हम कर्व्स के बेस में ऐसे करके रिप्रेजेंट कर सकते हैं। देखिए जैसे ये है, इस साइड पे आप ले लीजिए kinetic energy of molecules और इस साइड पे हम लेंगे fraction of molecule having energy equal to or more than threshold energy. Fraction of molecule इसको लिखेंगे delta n by n. So this will be like this. When you increase the temperature, okay, so this is again the kinetic energy, again the delta n by n. So we have two curves like this. Okay, when you increase the temperature from T1 to T2, you get another curve. So area, if you say this is the area under the curve, and when we increase the temperature by T2, T1, so T2 is greater than T1, so area under the curve become almost double. This represents that when the temperature is increased by 10 degree, what is the difference between T2 and T1? You can say that T2 minus T1 equal to 10 Kelvin. So area under the curve become double, which represent the molecule having energy more than this is the threshold energy. Okay. So when we increase the temperature, the molecule having energy equal to or more than threshold energy become almost double. That's why the rate of reaction become double. Okay. So this is the reason why with increase in temperature the rate of reaction become almost double or 3 times. Now we have some problems based upon it. If the rate of reaction at 25 degree Celsius is say R, and temperature coefficient is alpha, then calculate rate of reaction, then calculate rate of reaction at 35 degree, 45 degree, 55 degree and 65 degrees Celsius. This is your problem number 1. So now how to solve this? We know that the rate of at 25 degree is R. Temperature coefficient is alpha. What is alpha by definition? 35 degree to 25 degree. It means rate at 35 degree become equal to, so move here, so this become equal to alpha R. Okay. Again, rate at 45 degree by rate at 35 degree is again R, sorry, alpha. This is also temperature coefficient. Temperature difference must be 10 degree. This is R. Now what is from here we can calculate rate at 45 degree. तो ये इधर चला गया, 35 की वैल्यू क्या है? अल्फा आर, अल्फा आर, तो ये बन गया हमारा अल्फा स्क्वायर आर. सेम इफ यू राइट 55 डिग्री सेल्सियस, 45 डिग्री सेल्सियस, अगेन अल्फा. तो अगर आपने 55 डिग्री पे निकालना है तो ये बन जाएगा अल्फा क्यूब आर. और अगर 65 पे निकालना है तो ये बन जाएगा अल्फा रेज़ पावर 4 आर. Okay. Okay. Next, second problem. For first order reaction, have some rate, same rate. So लिखते हैं 2 first order reactions have same rate at 25 degrees Celsius. Same rate at 25 degrees Celsius. If Tc for first is 2 and second is 3, then calculate ratio of rate of reaction. Then calculate ratio of rate of reaction at 75 degrees Celsius. Pause the video and try the problem. Okay. So, how to solve it? First reaction, what is here? Tc is 2. If we say that rate at 25 degree is R, what will be the rate at 75 degree if the temperature coefficient is 2? It will be 2 raised power 5 R. Second reaction. Now the temperature coefficient is 3. Again, rate at 25 degrees R. What will be the rate at 75 degree when the temperature coefficient is 3? So 3 raised power 5 R. Now take the ratio. R1 for this, R2 for this. So R1 by R2 at 75 degree. That will be equal to R cut jayega 2 by 3 power 5. So this is your answer. Okay. So this is about the effect of temperature. अब इसमें एक छोटा सा कंसेप्ट आता है, कंसेप्ट ऑफ एक्टिवेशन एनर्जी. Concept of activation energy, EA. अब मान लो we have a reactant A and B. So for the reaction to take place, A and B must have a minimum amount of energy that is known as a threshold energy. Here, suppose we have A and B change into product. So for reaction to take place, A and B must have certain minimum amount of energy called threshold energy. अगर ए और बी के पास एनर्जी थ्रेशोल्ड एनर्जी से कम है, देन दे विल नॉट रिएक्ट टू गिव प्रोडक्ट. और अगर हम चाहते हैं कि रिएक्शन हो, देन वी हैव टू सप्लाई एनर्जी फ्रॉम आउटसाइड. So that energy which we supply to A and B to make its energy equal to or more than threshold, so then that they can react, that extra amount of energy supplied is called activation energy. What is activation energy? Extra amount of energy which has to be supplied to the reacting species so that they react, or you can say in order to make their energy equal to threshold energy. Is known as activation energy. Why we use the word activation? Because actually we are activating. A and B के पास एनर्जी नहीं थी, कम थी थ्रेशोल्ड से, क्योंकि मिनिमम अमाउंट ऑफ एनर्जी उनको चाहिए, तो वो रिएक्ट नहीं कर पा रहे थे. हमने क्या किया, एक्स्ट्रा एनर्जी दे दी बाहर से. तो एक्स्ट्रा एनर्जी देने से क्या हो गया, उनकी एनर्जी थ्रेशोल्ड के इक्वल होगी. नाउ दे बिकम एक्टिव. Active means they can react. That's why the word activation energy is there. So we can write activation energy equal to threshold energy minus normal energy of the reactant. Threshold energy minus normal energy of reactants. So this is the relation between the activation energy and that of the threshold energy. Now, how to show the activation energy in case of endo and exothermic reactions? Let's see. And what happened if we how you can compare the rate of reaction while we know the activation energy. So suppose we have a reactant A to form product, B to form product. A and B require same amount of energy to react. इसको हमने 50 joule energy दे दी, इसको हमने 100 joule energy दे दी. This is activation energy which we supply. Which reaction will be fast? This will be faster. Why? Because lesser amount of energy is required. तो इसके जो मॉलिक्यूल हैं, इस उनके पास पहले से एनर्जी सफिशिएंट है. So in this case, lesser amount of energy is you can say supplied to the reactant molecule. Now suppose we progress of reaction on the basis of activation energy कैसे करेंगे? Suppose we have a रिएक्शन ए बी, जिसकी एक्टिवेशन एनर्जी कम होगी उतनी ही रिएक्शन क्या होगी, फास्ट होगी. हम लिख लेते हैं यहां लो ईए फास्ट रिएक्शन. सपोज वी हैव नाउ ए बी प्लस सी टू फॉर्म ए सी प्लस बी. We will see the progress of this reaction in the graph. In this case, we will write progress of reaction. You can say time, and in this side, we will say the potential energy. Here are the A, B plus C. They react to form AC plus B like this. So at this distance from here to here, this is actually the activation energy. Energy required to make the complex, because at this point we get a activated complex like this. So this is the activated complex which is formed here, and after that product is formed. So energy is required to make the activated complex because A, B plus C do not have a sufficient amount of energy to form an activated complex. So we must supply energy, means this reactant must cross this barrier to change into product. So now this is activation. So this activation energy is less. अगर यहाँ पे होती तो it's easy to cross the barrier. That's why I said that if low activation energy is there, reaction will be faster. Okay. So for endothermic and exothermic, how we can draw the structure of this energy profile diagram for endo and exo. So this is say we will draw endo and for exo. Okay. So suppose we have in this side we have a progress of reaction. In this side we have energy, and we have a potential energy, we have a progress of reaction. Now how to make? Suppose reactant is here, product is here. Energy of product is less than reactant. It means reactant has lose some energy. So this is for exothermic. Opposite to this is if the reactant is here, product is here. So this is endo. Here the energy of product is more. Now, where do you find the activation energy? If the reaction is proceed in a reverse manner, like A plus B, C plus D. See, here we have a plus B, and here we have a C plus D. Here we have a plus B. Here we have a C plus D. Reversible. This difference, this point to this point, this top point is activation complex. Okay, so this distance from here to here, this is activation energy for forward process. Energy difference between reactant and product, this is simply delta H enthalpy change. That will be negative for exo and positive for endo. And from here to here, this is the activation energy for backward. So here the forward process is more feasible than backward, because in case of forward, when we move from A to B to C D, then activation energy is less as compared to backward. Forward process is more feasible. Why is more feasible? Because product energy is less. Everybody wants to get stability. एक बी आर की एनर्जी ज्यादा है, पी की कम है, तो एनर्जी कम मतलब स्टेबिलिटी ज्यादा. दूसरे में देखिए, if you see the forward from here to here, this is your activation energy forward process, and this difference is again delta H. From this point to this point, this is your activation energy for backward. Here the activation energy for backward is less. It means backward process is feasible. Why? Because product is more energy than reactant. The product is less stable, so want to become more stable. So that's why the backward process is feasible. So this is about the activation energy concept and explanation on the basis of this. इस ग्राफ के बेस पे प्रॉब्लम्स भी आती हैं, न्यूमेरिकल प्रॉब्लम्स पूछते हैं, आपको ये वैल्यू दे दी, ये वैल्यू दे दी, डेल्टा एच पूछ लेंगे, डेल्टा एच दे दिया, ये दे दिया. अब देखो ई ए बैकवर्ड की जो एक्टिवेशन एनर्जी, दैट इज द सम ऑफ दीज टू. यहाँ पे फॉरवर्ड की जो बैकवर्ड एनर्जी है, दैट इज सम ऑफ दीज टू. तो इसके बेस पे आपको प्रॉब्लम भी पूछ सकते हैं. दिस इज अबाउट द इफेक्ट ऑफ टेम्परेचर. अब इसको एक्सप्लेन करने के लिए हमारे पास एक बहुत ही इंपॉर्टेंट टॉपिक इसका है, दैट इज अरेनियंस इक्वेशन. तो आगे हम अरेनियंस इक्वेशन जो है वो करेंगे.